can happen to you. So, and I say you, I mean the New York Lottery Commission. So here, top, you guys have seen Keno in the bars around here, I'm assuming. At least heard about Keno. It's essentially the same game. You got a bunch of numbers, you're picking some of them. Here's the normal payoffs for this game of whatever it is, pick 4.
Yeah.
What was your average payout for the normal game?
Negative 41 cents.
Negative 41 cents, which means instead of playing the damn game, just walk up, hand them 41 cents and walk away. Because that's what's going to happen on average every single time you play, right? Because you're paying for the privilege of playing. You're paying for the privilege of playing the game. Is that fair? Is the fact that it's negative make sense? I think it makes sense because they have to do things like print tickets, pay their employees, have commercials, they have income from you. So what they decided was business was lagging. Nobody's playing Play 4 enough. What can we do to institute interest in Play 4? I know! Double the payouts, right? Double the payouts. So they went in here and they said, okay, make 55 to 1, 110 to 1. That means you clear $109. Make 5 to 1, or make 5 to 1, 10 to 1, so you clear 9. Make 1 to 1, 2 to 1, so you clear 1. That's the biggest one, FYI. The 2 to 1 was the biggest impact on the profit, which is incredible. Because it went from 0 to 1. It's basically almost a mathematically infinite jump. But you rerun the average, and what do you get? Say that again. Say that again. Nice and loud. Not, that was quieter. What didn't you say before the 19?
Negative.
Negative. So this is like walking up there with your hand out going, I'll take my 19 cents now. But you have to buy a ticket. No, not on average I don't. Because you're going to owe me 19 cents for this, right? You're going to owe me 19 cents. And the kids figured this out. Remember, they are still losing 75% of the time. They're still losing 74.1, 75% of the time. So if you compare this to the Chuck-a-Luck probabilities, remember this right here? This is the highest probability, is losing. So you're negative when you start. The problem with Chuck-a-Luck is, once we got down to where you were making money, you didn't make up enough money to offset that negative. But what happened with Play 4? You did make up enough money to offset that negative. It became positive. In other words, whatever money you put in, you're going to have 120% of the money you get out by the time you're done. Anybody got a bank account that pays like that? No, so put your money in that, which is what these kids did for 4 straight days.
Is this true?
It is totally true. Happened in 2006. And you know what blows my mind is, how often does this kind of crap happen and nobody notices? That's what I think about. So next time you're anywhere where Keno is played, see if they've changed any of the rules or the payouts. Just see. And then bring it back to me, let's analyze it. We'll go in handsies. I'll do the math, you bring me the information, we'll make lots of money. That's all, my friends. If you want to make it a quiz, I think you should. Drop them off up here. I'll get them graded over the weekend, get you guys further support next week. You guys rock. Most important part of this class, in my opinion, in my humble opinion.
In this scenario, when it draws 20 numbers, does it allow repeats?
Yeah. No, that's why, did you notice I gave you an extra credit option for failed probabilities? It's not independent sampling, it's very much dependent, and it's something called the hypergeometric distribution. It's freaking awesome. It's the same one Powerball uses. It's basically Powerball. There's 80 balls in a bin, and you're pulling them out without putting them back in, not without replacement. Yeah. Or not with replacement, without replacement.
20, 80, 19,
Exactly, 20, 19, 18, 17, and so forth, down, down, down. Does that make sense?
Yeah. I mean, I got the first one.
Good!
But then,
because then you have to figure out which ones are matching and which ones aren't. The end ones are going to be easier than the middle ones, just like on the Chuck-a-Luck one up here. Yeah. Give me a couple minutes, Tom, we'll talk. Yes.
So, okay, like on a card that has 10 numbers.
Okay.
So let's, you know,
10 digits, 0 through 9.
How do you find the probability of finding the code? My son went out and found the code because we bought it, so we did it. And I was like, yeah, I just figured out. I can't figure it out. It's now they're like 10 minutes. So the code is 5 digits long.
5 digits long, okay.
But it has 10 digits on it, and we didn't know it was 5 digits long.
Okay, so in other words, this is good. So, is this your car or the door?
The car door has these numbers on it.
Oh, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then you have to punch 5 of them.
Yep.
So can you use the same number more than once? You can't you? Because it could be 1, 1, 1, 1, 1.
It does, yeah.
Okay, so essentially, there are 5 digits, not 10, because a button doesn't, you know the number. But if the number's 1, 2, 3, 4, 5, you go bop, 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 bop. It doesn't know if you're pushing a 1 or a 2, so there's 5 choices for each number. You have to pick 5 of them. So it becomes 5 to the 5th power, which is a very, very large number. If you think about that, that's a pretty, or excuse me, it's
31.
right, it's
3125.
right, exactly. But it's not so huge that you can't brute force it. And worst case scenario, it would be 0, 0, 0, 0, 0, and you have to wait till the very end to get it. Most likely it's somewhere in the middle, which would be 1600. So theoretically, assuming no lockout, he could just keep trying them. It's the same story I told you guys about me cracking my friend's little password. Can I tell you that story?
Yeah.
The little password thing. It's the same thing.
Two
It's like
digits long.
2 digits long, so I had 100 possibilities. He has 1600 on average. He could figure it out.
Yeah.
But
He
it's,
did.
it's
He figured
brute
it out like
force.
10 minutes.
Right, it's brute force unless there's some other key that says, you know, you can't
buttons
use
that are
more
dirty.
than. Say that
The
again.
buttons that are dirty.
I never thought about that. The Valley
movies
Forge
where they're looking at like the
Yes!
like in Seeker's what it is, where they like take little
or
dots,
National Treasure.
blow it onto the keypad and like whichever
Look
one
for
sticks is the one that
fingerprints.
people touch. Because ours, like, because we have the same keypad on our doors to our house and our garage. Same thing. It lists 1 through 5 and then 6 through 10. And like there's only 5 buttons. You know,
Right.
And we use 3 numbers, but it's only on 2 buttons.
Right.
So you'd be, yeah.
It's just a math. In other words, if there was a cool, I was thinking purely mathematically, but if you apply this to a 2, then it brings it out even more. Your next project, just FYI, your next project, the first thing it analyzes is passwords and why your banner password is the way it is. Because if you brute force try to crack it, it would take you something like 18 trillion years to brute force crack it. And that's why passwords are good. I actually can I tell you, I thank Jessie, who runs Banner. I sent her a note, I'm like, thank you for this. She's like, for what? I'm like, for making the password be what it is. She's like, why you thank me? And I gave her the math. She's like, I didn't know that. She had an intuitive
She's
feel.
going industry standards.
She's going industry standards, but the industry standard is good enough to realize it's going to be impossible to crack. It wouldn't be like your door. So, I mean, it could be. Did you guys set your car password, or it came that way from the factory?
We bought
Right.
it used, and it had one on it, and he just
Gotcha.
figured it out. And I'm like, how scary is that for somebody who just
Right. But it's not that he guessed it right on the first. It's that he probably brute forced a few, and he happened to
He
hit
went
it.
through it, yeah.
Exactly.
I knew that it was probably like one number, then 2 of the same, then 1. and
He
then- but
understands
that's what we
random
were kinda
plumbing.
like
This is your
doing.
son?
Yeah.
So proud of him. He understands random plumbing. It's most likely not 5 discrete numbers.
Yeah.
There's most likely a repeat in there somewhere. And then you just start trying possibilities. As long as you're trying sequentially so you don't double back on yourself. But yeah, I mean, that's, when you said it first, you said, I thought I heard you say,
Yeah.
it was a 10-digit
Yeah.
password with 10 possibilities for each. I'm like, there's no way he found that.
Yeah.
That's 10 to the 10th. That's 10, what's 10 to the 10th? 10 billion
Which
possibilities?
Dimitri.
But going from 10 billion to 3,000, I'm like, oh, no big deal. We can
The
totally do
nerd
that.
who has been watching your videos since I started class, he's like, oh, it's so cool.
That's cool.
Oh, that makes my day. Twice. Maybe that twice, Andrea. No, 3 times if you count last night when I say, whatever, I got it right. That's my favorite comment.
Is that what she said to David?
The Facebook, it started with an I believe.
Yeah, it was, no.
No, I got it right. It was just such a great comment. Did you see the string?
No, I didn't even.
Check it out if you get a chance. It's a string. Poor Dave. He's never gonna live this
I know,
down.
but
But he was trying to say that 1/2 times 1/2 is not the same as 1 cubed over 2 cubed. And I read that, I was like, dude, you're wrong.
Well, then he
I'm
made
sorry.
a full own comment about it, his whole own post about
He made his
that.
own
And I'm like,
post.
actually, people don't
I noticed a
know.
lot of people in here are confusing, and I'm like, oh, you didn't just do that. And then I saw that one first, though, Andrea. So then I started going through, and I saw how many other times he had commented, and I'm like, oh my god, he's trolling himself. This poor guy. He's done a calculation. David, you're watching this. I'm sorry, brother. He's done a calculation